Okay, so we're going to look at the key for section 1.4 on worksheet 3. And so this one is the section with higher order equations. And on this problem, you're going to be using the GCF and factor by grouping. And notice the statement right here says write the final statement. This should be statement as the solutions are. Okay, so let's look at the first one. So here's the first one. So we have this polynomial equation, and the first thing you want to do is you want to write this in standard form. So basically you want to have 0 on one side. So let's go ahead and subtract 80x squared from both sides. And so when I do that, I'm going to get 5x to the fourth minus 80x squared equal 0. Okay, so the fact that I have two terms here, and I also see that this coefficient is 5, and this coefficient of x squared, if you think of this as adding up the opposite, is a negative 80. And you also see that both of those terms have factors of x. So we can look at the GCF. So the GCF in this expression right here on the left side is going to be 5x squared. All right, so the GCF is 5x squared. So the largest number that goes into 5 and 80 is 5. And for the variables, remember if you have factors of a variable raised to a power, the GCF is always going to be the one with the smallest exponent. So that's where we get that 5x squared. So now once we found that GCF is 5x squared, you're going to rewrite this left-hand side using the GCF. So since the GCF is 5x squared, I can factor the left-hand side as the GCF times some expression that's going to give me this original expression back. So 5x squared times what will be 5x to the fourth. And so you know that that's going to be x squared. Because if you distribute 5x squared times x squared is 5x to the fourth. Minus, and then 5 times what is 80. So basically, if you can't do that in your head real quick, you just say 80 divided by 5, right? So 80 divided by 5 is 16. Now, notice that this was x squared. I'm factoring out an x squared, so there's no other variable, factors of the variable that goes here, factors of x that goes here. So this right here is the factorization for that. Now, I can go ahead and factor this a little bit further, but in terms of factoring out the GCF, what I have so far is correct. All right. Now, you can do one of two things at this point. You can notice that this binomial right here is the difference of two squares, and you can factor further. So let's go ahead and do that approach, and then I'll show you what else you could have done. But at this point, there are really two processes you could go through. So you could say, well, I'm going to go ahead and factor the difference of two squares. So this will be x minus 4 times x plus 4, right? And that's equal to 0. And we know using a zero factor property, and so I'm saying the zero factor property, so let me go ahead and write that right here. Zero factor property, so we've talked about that before, and you've had that in a previous course. So the zero factor property states that I set each of these factors equal to 0. So a factor, so I'm gonna underline the factors that contain variable expressions. So this one as well. Okay. What many students though is they take this monomial right here, which is comprised of several factors, 5 and 2 factors of x, and they set each of those equal to 0. So the zero factor property says if you have a product of factors, which I do here, then one of those factors has to be 0. That's the only way I can get that product to be 0. So we're going to say I'm going to set 5x squared equal to 0. I'm going to set x minus 4 equal to 0. And I'm going to set x plus 4 equal to 0, right? Now I'm going to start with this one because this one's easy. So we have this linear equation, and I know that since the coefficient of x here is 1, then I can quickly get the solution by just adding 4 to both sides. So there's one of my solutions. So one of your solutions is 4. Over here I have this linear equation also, so I'm going to subtract 4 from both sides, and so I get x to equal negative 4. Now over here, you can do one of two things. You can intuitively think about what the solution is, because this is a monomial, right? And so this monomial has to equal 0. Well, in order for that to happen, if you think about it, you're asking yourself 5 times what number squared is 0? Well, in order for 5x squared to equal 0, then x must be 0. So intuitively, you could have just said x is 0, right? Now, just to let you know, if you want to do this, if you want to kind of go through the process without intuitively think about this in your mind, although this is fine right here, you could have said this. Let me just kind of show you here. So you could have said, well, I have 5x squared equal to 0. So I have this quadratic equation, right? I have this quadratic equation. And if I'm going to get x squared by itself, I'm going to go ahead and divide both sides by 5, right? And so 5 divided by 5 is 1. So I get x squared equal, and then 0 divided by 5 is 0. And then I can use the square root property. So we talked about the square root property, so I'm going to take the square root of both sides, right? So I get plus or minus over here. So I get the square and the square root undo each other, so I get x equal, and then the square root of 0 is 0, right? So I get plus or minus 0, which is just 0. All right, so you could think of this intuitive like we did, or you can go through the process. It does not matter. All right, and so notice that this equation right here, this polynomial equation, has 3 distinct solutions. All right, 3 distinct solutions. So you'll say something like this. You'll say the solutions are x equals 0, 4, and negative 4. Okay? Now, let me just remind you. So at this point, many of you recognize that this was the difference of two squares, and you factored further. Okay, so you could have done this as well. So let me just kind of show you. So at this point, going from here to here, let me go ahead and rewrite this over. You have 5x squared times x squared minus 16, right? And so at this point, you can use the zero factor property. So you could say, well, I have this factor right here, which is composed of several factors, but let's think of this as a monomial factor times this binomial. So I have this times this, and that product is 0. So according to the zero factor property, I have to set each of those factors equal to 0 because one of them has to be 0, right? And so notice I have these two quadratic equations that I have to deal with. So this one's the same. The thought process is here is the same as this one, right? So we know that x has equals 0 here. And over here, I know that I can use the square root property because there's no x term. I see an x squared and I see a constant. There's no x term. So now I know I can use the square root property. So I'm going to go ahead and add 16 to both sides. So I get this. And then just like we did here, where I took the square root of both sides, you can do the same thing here. So I'm going to take the square root of both sides. Don't forget, though, plus or minus. So the square and the square root undo each other. So I get x equal plus or minus, and the square root of 16 is 4. And so you see that plus or minus 4, that's this right here, right here. And so you'd say the solutions are x equals 0, 4, and negative 4. If you want to, you can say this as well, x equals 0 plus or minus 4. Does not matter. All right, but you have 3 distinct solutions, 3 unique solutions there. Okay? All right, so that is number 1. Okay? That is number 1. And so notice that, okay, so let's just leave it at that. So 3 distinct solutions. So that's number 1. So let's get number 2. So here's number 2. So in number 2, we have this equation. That's number 2. We have 3x to the 5th plus 27x cubed equals 0. Okay, so let's find the GCF. I have 2 terms. I know that 3 and 27, the GCF of 3 and 27 is 3. And for x to the 5th and x cubed, I know the GCF is x cubed. So the GCF here, so I can solve this equation by factoring out a GCF first. So the GCF is 3x cubed. So once I find the GCF, I'm going to rewrite the left-hand side. Remember, it's already in standard form. You already have 0 there. So I'm going to rewrite the left-hand side using this GCF. So I get the GCF, which is 3x cubed. And so you just go through the same process like we did with this one. So you're going to use the distributive property to help you. So 3x cubed times x squared is 3x to the 5th. 3 times a positive 9 is 27, and notice this is x cubed. I'm factoring out an x cubed, so I don't need any more factors of x. So I get equals 0, and so we're at this step now. Now, be a little bit careful here. So remember, I could have gone further here because this is the difference of two squares, and so I know how to factor the difference of two squares over the integers. But over here, this is the sum of two squares, and so we learned in the past that over the integers, the sum of two squares cannot be factored. So then you're forced to look at these two factors separately. So I'm going to use the zero factor property at this point. So the zero factor property. And so when I do that, I get 3x squared equals 0, x squared plus 9 equals 0. Okay? All right, so the same thought processes we did with this right here still applies here. Or if you want to, you could do this intuitively like we did here. Okay? So meaning this. I know that this monomial factor here has to equal 0. This product, 3 times x squared, has to equal 0. And I know that in order for that to happen, this x has to be 0 because 3 times 0 squared is 0. Okay? So I know that's one of my solutions. Now over here, you got to be careful. So this is sum of two squares, and you know all about the imaginary units. So you have to, you cannot say there's no real solution. You're right, there's no real solution, but you also know how to write solutions that are imaginary. So you have to use that fact. So we're going to bring 9 to the other side, so I'm subtract 9 from both sides, and so I get x squared equal negative 9. So now I know it's in this form where I can use the square root property. So let me go ahead and rewrite this over. So now I'm going to take the square root of both sides. Don't forget plus or minus. The square and the square root undo each other. So I get x equal plus or minus. And we know that the square root of a negative 1 is equal to I, right? And so the square root of a negative 9 would be the square root of a negative 1 times the square root of 9. So the square root of negative 1 is I times, and then the square root of 9, 9 is a perfect square. The square root of 9 is 3, so this becomes 3i. So I get plus or minus 3i. And so your three distinct solutions are, so the solutions are, remember the direction set to write it like this, the solutions are, and you'll say x equals 0, x equal 3i, x equal negative 3i, or you could say x equals 0, x equal plus or minus 3i. Okay? All right, so that's number 2. So not difficult at all, fairly simple process. All right, let's look at number 3. So in number 3, the way you want to do number 3 is you got to remember something about factoring from a previous semester. So you have x cubed plus 2x squared minus 9x minus 18 equals 0. So remember in previous semester when you had four terms, one of the ideas that you used was factor by grouping. All right, factor by grouping. So you want to try and see if this polynomial that's on the left, and it's already in standard form because you have 0 on this side and it's in descending order. So you want to see if what you have on the left is factorable by grouping. Okay, so let's see. So normally what's going to happen, that's not always the case though, but normally what's going to happen is you're going to try to group the first two first and the last two terms. All right, so from the first group right here, from that first group, I'm going to group the first two terms together. I know that the GCF is x squared. So I can factor out an x squared from that first group. So from that first group right here, and if you need to, then just go ahead and cover up this other part so you don't have all this in front of you. So you just want to factor this first group. So from this first group, I can factor in an x squared, and I get x squared times x is x cubed, and then plus, and then x squared times 2 is 2x squared. X squared times 2, so that should be 2 right here. So this is, oops, sorry, let me rewrite this over. So factor in x squared, right? So I get x squared times x squared times x is x cubed, and then plus 2, okay? So always check, x squared times x is x cubed, and then x squared times 2 is 2x squared. All right, so from the second group right here, now be careful, you always want to factor out with that sign right here. So that's a negative, so you're going to factor out a negative GCF. So notice that these two terms, the GCF is a 9. 9 goes into negative 9x, and 9 goes into negative 18, right? So I can factor out a negative 9. Always factor out that sign that you see in the middle, right here. I'm going to factor out a negative 9. When I do that, I get negative 9 times what is a negative 9x. So we know that's x, because negative 9 times x is a negative 9x. Now be careful, a negative times what is a negative? So we know that a negative times a positive is a negative. So that should be a plus sign right here. And a negative 9 times a positive 2 is a negative 18. If this polynomial that's on the left-hand side is factorable by grouping, and if we're doing the process correct, these two factors that are in parentheses, this factor and this factor, should be the same. And they are. So now I can factor out an x plus 2. So I get x plus 2. So when don't forget to put 0 here. So when I factor out an x plus 2, when I take this x plus 2 out, when I factor that out, I'm left with x squared, right? And then when I factor this x plus 2 out, I'm left with minus 9. And then that's going to equal 0. So notice this right here is this. Because look, x plus 2 times x squared, if you think about the distributive property, that's this. And then x plus 2 times a negative 9, that's this. Okay? All right, and then you could do the same way we did number 1 if you want to, because notice this right here is the sum of, the difference of two squares. And so you could factor the difference of two squares like we did here, right? So you could say, well, that's going to be x plus 2 times x minus 3 times x plus 3, correct? And now, I'm going to use a zero factor property. So one of those factors has to be 0. So I have a product of factors that's 0. So one of them has to be 0. So I'm going to set each of those equal to 0, just like this. Oops, equals 0. And we solve each of those linear equations. So over here, x equals negative 2. So there's one of your solutions. Over here, x equals 3, right? And over here, x equals negative 3. So those are your three solutions. So the solutions are x equal negative 2, 3, and negative 3. Or if you want to, you can write as x equal negative 2 plus or minus 3. Okay? All right, so that was number 3. And then finally, let's look at number 4. So number 4, so it's not a very difficult process because you know all about factor by grouping. And so you just have to use that here. So number 4, we have this equation. We have x squared minus x cubed minus 3x squared plus 6x minus 18 equals 0. Okay, so I have 4 terms. And so I'm going to solve this equation that's already in standard form. I have 0 on this side. It's in descending order. So I'm going to solve this equation by factor by grouping. So let's go ahead and group the first 2 and the last 2, right? And so if you need to cover up this part right here, then do that. So in that first group, I know I can factor out an x squared. The GCF is x squared. So I'm going to say x squared times. So x squared times x is x cubed minus, and then x squared times 3 is negative 3x squared. Okay, now let's look at that second group. Now you see, always factor out that symbol, that operation that's right here. So I'm going to factor out a positive GCF here. So over here, these two factors have a 6 in common. So that's the GCF, 6. Now there's a 3, but remember, 3 is not the GCF. 3 is a common factor. It's just not the GCF. So always factor out the GCF. Okay, so I'm going to factor out a 6. So when I do that, I get 6 times x minus 3, because 6 times x is 6x. 6 times a negative 3 is a negative 18. And then notice, these two factors are the same that's in parentheses. So now we're going to factor, don't forget to say equals 0. So then we're going to factor out the x minus 3. And when I do that, when I factor out that x minus 3, I get x squared in parentheses. And over here, when I factor out that x minus 3, I get plus 6. Okay? All right, and so now now I have two factors. Now, by the way, this is not the difference of two squares. This is not the sum of two squares over the integers, because 6 is not a perfect square. But I can still find the solutions in terms of imaginary numbers. Okay, so let's look at that. Okay, so So I'm going to say each of those factors equal to 0. So I get x minus 3 equals 0, x squared plus 6 equals 0. So I have a linear equation and I have a quadratic equation, right? So this linear equation is easy. So I'm just going to go ahead and add 3 to both sides. So one of my solutions is 3. So I get a real solution. So one of my real solutions is 3. Over here, though, the best way to solve this is first notice there's no x term. There's an x squared, no x. So I'm going to use the square root property here. So to use the square root property, I need to subtract 6 from both sides. And so I get x squared equal a negative 6, right? And so now, since I have this x squared by itself, I know I can use the square root property, just like this. Don't forget, though, you get plus or minus. So the square and the square root undo each other. So you get x equal plus or minus, and then square root of negative 6. Well, let's think about what that square root of a negative 6 is. All right, so I know that I can rewrite the square root of a negative 6 as the square root of a negative 1 times the square root of 6. And I know that the square root of a negative 1 is defined to be the imaginary unit I. Now, you need to simplify these radicals as much as possible. So the square root of 6, I cannot simplify. So this I can't simplify, right? I cannot simplify further. And so therefore, you just rewrite it just like that. And so we get, so this right here is just this right here. So we get plus or minus I square root of 6. All right, now, see this right here? If you want to put the symbol I, that imaginary unit I, on the back end, be careful. So remember, don't put I underneath that square root, right? Because I is defined to be square root of a negative 1. So be careful. So when you put on the back end, make sure it looks like this, square root of 6, and then make sure that I is not appearing under that square root. Because if you do, that's incorrect. All right, so remember, I is square root of negative 1. So this is square root of 6 times the square root of negative 1. Okay? All right, so there's your three solutions in this case. So one is real, the other one is imaginary. Okay? All right, so you're going to say the solutions are x equal 3 plus or minus the square root of 6i. Remember, don't make it look like I is underneath. Or you can say x equal 3. I'm going to write it like this: I square root of 6 negative I square root of 6. Okay? So I tend to, when it's a square root involved, I tend to put I in front of the square root. All right, so that's it. So that is the key to this worksheet on section 1.4, worksheet 3.